Hey everybody, thank you for clicking on my video. I really appreciate it. If you haven't subscribed, please consider doing so. So for those that are new, what I do on this channel is I take electronic projects from old electronic magazines and then I bring them to life. I etch the board, put the parts on it, I troubleshoot, I test it, and if it works, I put it in a case. That's what I do. Before we go any further, I just need to let you all know that I'm not smart. I'm just a tech at the very most. However, I learn a lot from these videos and I get a lot of feedback, which is great. So thank you for that. All right, so today's project does not come from a magazine. So this is one of those unusual ones, but it comes from a basic need, right? So what we're going to build, as you can tell from the title, we're going to build a dummy load. And I went ahead and I've actually purchased these non-inductive loads. I got it from DigiKey. And yes, they're pricey. They're $31.28. Now that's Canadian, so I'm sure it's a little bit cheaper in American money. However, the one I bought is a 100-watt 8-ohm resistor, and I bought the 4-ohm resistor too. So I've got two big resistors. So the plan is to use them as a dummy load, of course, for audio equipment. I have one already, and I'll show you that in a bit. It's okay, but it uses wire-wound resistors, so it's a bit inductive, right? In any event, I'm showing you the data sheet right now, and the ones that I bought are about this big, so they're the bigger, what do they call them? TO247 style package. And yeah, so it goes up to 100 watts, derated to 0 at 175 degrees. Hopefully I don't get that high. And they've got this coating on here, and I've first time hearing about this, but it's an exposed ceramic heat dissipating mounting surface. But I still need thermal grease for this. I read through this data sheet and it still requires it, which is fine. I've got lots of it. And yeah, so I guess, you know, what can I say? It's pretty simple. It's essentially a resistor. So let me bring you to what I've got and we'll see if the design works out. All right, so this is what I have been using all this time. So as you can see, it's got a whole bunch of wire-wound resistors in there. And I know when I tested, especially my stereo, I think that's about 40 or 50 watts RMS, I think. This thing got hot. And in fact, I just actually just glued the terminal tie strips down. So that's the, that glue gun stuff, right? And it actually came off when it got really hot. So it's not that great of a design. So I definitely need to upgrade. Anyway, let's talk about the upgrade. All right, well, here's the upgrade. So, yeah, I had this big old heat sink somewhere in the pot. I've got a couple big ones, actually. In any event, this one I think is going to be perfect. It's pretty big. And I've got this chunk of aluminum here, too. And it's got bolts already. I'm going to use that bolt there and that one there. What more can I ask for, right? And then I'll make these banana plugs kind of up, maybe on a piece of scrap sheet metal or something like that. And then I'll be able to connect the actual banana plugs. I guess these are banana connectors, right? And it's going to be that simple, right? So I'm glad I got two because I sometimes have to test a 4-ohm equipment and also 8-ohm. So that's why I got both. And yeah, I mean, I don't know, maybe if things get really, really worse, or really, really bad, that's better English, I could put a fan, right? Maybe two small 12-volt fans, but on the back and around that. But we're going to see. When I build this thing, I'll put my stereo on it and I'll just crank it and we'll see what we get. All right, so that's the plan. Let me get on with building it.
We've been living in sin so long, all the feels are gone. Fella stopped me on the street last night, said everything's alright. Roller coaster, make it through the seem to easily forget how to place your bet. When everyday life gets you down, you gotta steal the crown. Got to own it. Don't bitch and moan about it, please. God forbid you scrape your knees, and it's nothing to sneeze at. Oh, I've told you over and over again. You gotta get both hands around it and make your own plans. Roller coaster, it's taking over. It's about time. Oh, sing your high line on the roller coaster of life. You've got to all choose your timeline with the roller coaster of life. Roller coaster. I want to go down the rabbit hole, down the rabbit hole.
All right, so as you can see, it's done. I think it's a pretty good dummy load for a homemade dummy load. Yeah, so these brackets up here, by the way, they are to protect the actual leads underneath the resistor. I just don't want something landing on it and then actually potentially breaking them. So it's a little bit of protection. It's not a lot, but it's a little bit. And as you can see, I've got L brackets here for the binding posts. And what else can I say? That's it. Well, this is 8 ohm resistor. That's the 4 ohm. Let's measure it. So try the 4 ohm first. There you go. And there's the 8 ohms. And if I short the leads, there's a 0.1 ohm resistance there. They are 1% resistors, by the way. And also I made these cables here so we can hook them up to a speaker, or sorry, no, to a stereo. Anyway, it's Friday. It's late. I'm tired. I'm going to call it quits for today. And tomorrow what I'll do is I'll hook this thing up to a stereo and see how warm it gets. Okay, so it's the next day and I've got everything set up. So we're using a Luxman R1030 stereo, and according to the internet, it's got 30 watts per channel. And then we've got the dummy load, of course, at the bottom. And we've got the scope, and we've got a signal generator right here. So that's the setup. And let me just zoom you in on a specific item. Okay, so I'm showing you the scope, and I've got a times 10 probe on the scope. So everything is multiplied by 10. And I'm on the 1 volt scale. And right now I am inputting to the auxiliary jack on the stereo 60 millivolts. So let me just crank it up here, 1 kilohertz too, by the way. I'll crank it up just before clipping, and that's about it there. So I've got 5.5 divisions, right? 1, 2, 3, 4, 5, 5.5. Let's say 5.5. So that's 55 volts peak to peak. That's quite a bit. All right, and let's just do a quick power calculation, and let me show this to you here. All right, so a voltage RMS. So I've got this, well, I've got the power formula below it. So yeah, you put the 55 divided by 2.828, that gives you 19.448 volts RMS. And power is equal to VRMS squared over resistance of the speaker. And you get 47.27 watts. Yeah, that's quite a bit. It's only rated for 30, but whatever. That's the calculation. Hopefully I got the right formulas. Sometimes I get them mixed up, but I'm pretty sure I got them correct. In any event, if I don't, let me know. So yeah, I guess the main point that we're really trying to get is, how is the dummy load working? All right, so the most important thing for this video is the actual dummy load, right? How it's working. Oh, before I do that, I just realized that to get that power output that I just showed you on the last clip, I'm actually inputting 490 millivolts peak to peak. So I'm pretty sure when they do the power calculations on these stereos, they probably have like a standard input level. Who knows, maybe 300 millivolts, whatever it is. And that's probably where they get that 30 watt listed power. So I'm definitely overdriving it. But, you know, it's for this test, it's fine because I just want to see how hot this thing gets. And I'm pleased to announce that it's warm and I could touch that no problem. Well, I shouldn't say I don't barely feel anything, but it is getting warm. But thankfully, the actual heatsink is working really well. And even when I go on the left side, it's warm too. So the heat is being distributed. So I'm very grateful for that. Yeah, I'm quite happy with that. And I've had this thing running for at least maybe 45 minutes, more or less on high power. So it's really working well. Yeah. Well, there's really nothing more to be said, right? It's just a dummy load, but I'm grateful that I made it. I certainly will be using this in future videos for audio applications. And by the way, I think I'm going to pull the trigger and I'm going to buy the Quantasylum 403 for audio testing, right? So if I build an amplifier, I'll have at least something that's probably pretty reliable in my results. So I think I'll go ahead and do that. But thank you for watching. I really appreciate it. If you haven't checked out some of my other videos, please check them out. And don't forget to subscribe and like. Bye for now.